all my dear students. In this video we are going to derive the equation for DIF FFT algorithm. DIF is decimation in frequency fast Fourier transform algorithm. Decimation in frequency, in this is we are going to decimate the frequency components, whereas in DIT we have decimated the time components. Here we are going to decimate the frequency components. We will see what it is. X of k, this is your DFT formula. X of k is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi n k divided by n. So here I can write the PUDI factor e power minus j 2 pi n k divided by n is equal to Wn power nk. So I have substituted Wn power nk instead of e term. Okay. And from this expression I am dividing the limits into two halves. So 0 to n minus 1 can be divided into 0 to n by 2 minus 1 and n by 2 to n minus 1. This term can be divided into two limits. I am rewriting the equation as summation n equal to 0 to n by 2 minus 1 x of n Wn power nk plus summation n equal to n by 2 to n minus 1 x of n Wn power nk. Okay. So in the next expression I am rewriting this term as summation n equal to 0 to n by 2 minus 1 x of n Wn power nk plus summation n equal to 0. Here I am considering n plus n by 2 instead of n. So I am changing the limit also. Okay, n equal to 0 to n by 2 minus 1 x of n plus n by 2 Wn per k into n plus n by 2. Instead of n, I am substituting n plus n by 2. So the limit will be varied from 0 to n by 2 minus 1. Okay. Next step, summation n equal to 0 to n by 2 minus 1 x of n Wn per nk plus summation n equal to 0 to n by 2 minus 1 x of n plus n by 2 Wn per nk. I am multiplying this k with n and n by 2 and I am splitting the expression as Wn per nk into Wn power n by 2k. So this Wn power n by 2k can be written as e power minus j 2 pi k into n by 2 divided by n. So if you simplify, you will be getting e power minus j pi k. So e power minus j pi value is minus 1 power k. So I can write this expression as minus 1 power k. So I am going to substitute this one instead of this term. Okay. So x of k can be written as summation n equal to 0 to n by 2 minus 1 x of n Wn per nk plus minus 1 power k. Instead of this term, I am substituting minus 1 power k summation n equal to 0 to n by 2 minus 1 x of n plus n by 2 Wn power nk. Okay. So here I am taking summation as a common term and Wn power nk as a common term. And I am rewriting this expression as summation n equal to 0 to n by 2 minus 1 x of n plus minus 1 power k x of n plus n by 2 into Wn power nk. I am taking summation and Wn power nk as a common term and rewriting this expression. Okay. From this equation, I am splitting the term into two halves for even and odd. For even I am considering x of 2m. Okay. So if you substitute 0, you will be getting x of 0. If you substitute 1 instead of m, you will be getting x of 2. If you substitute 2, you will be getting x of 4. So I am getting the even terms for x of 2m. So for even I am substituting x of 2m is equal to summation n equal to 0 to n by 2 minus 1 x of n plus minus 1 power 2m. Instead of k I am substituting 2m. So here we have minus 1 power k. Here I am substituting minus 1 power 2m into x of n plus n by 2 into wn power n into 2m. Okay. So here minus 1 power 2 is plus 1. So here I am considering plus 1 and I am rewriting this expression as summation n equal to 0 to n by 2 minus 1 x of n plus n by 2 into w n by 2 power nm. This expression can be written as w n by 2 power nm. Okay, this is for even. Here this term can be considered as f1 of n. So f1 of n is equal to x of n plus x of n plus n by 2. I am substituting f1 of n instead of this term. I am rewriting this expression as x of 2m is equal to summation n equal to 0 to n by 2 minus 1 f1 of n, the total factor term wn by 2 power nm. Here m value varies from 0 to n by 2 minus 1. Okay, this is the expression for even function. Next one for odd, I am substituting 2m plus 1. Here when you substitute m as 0, you will be getting x of 0 plus 1 1. If you substitute m as 1, you will be getting x of 3, and if you substitute m as 2, you will be getting x of 5. I am getting the odd sequence. Okay, so I am substituting 2m plus 1 for odd. So instead of k, I am substituting 2m plus 1. Okay, for any values of m for odd term, you will be getting minus 1. That's why I am writing minus sign here. Okay, and rewrite this equation as summation n equal to 0 to n by 2 minus 1 x of n minus x of n plus n by 2 wn power n into 2m into wn power n. Here instead of k we have substituted 2m plus 1. This term can be splitted like this. Okay. In the next expression, here instead of wn power n into 2m, I can able to write wn by 2 power nm. Okay. I am rewriting this expression as x of 2m plus 1 is equal to summation n equal to 0 to n by 2 minus 1 f2 of n. This expression can be written as f2 of n wn by 2 power nm into wn power n. Okay. Now consider f1 of n and f2 of n. f1 of n is equal to x of n plus x of n plus n by 2 and f2 of n is equal to x of n minus x of n plus n by 2. Here I am going to substitute the different values for n. So when you substitute n as 0, you will be getting f1 of 0 is equal to x of 0 plus x of 4. Consider 8-point DFT. When n is equal to 8 by 2 will give you 4. When you substitute n is equal to 1, you will be getting f1 of 1 is equal to x of 1 plus x of 1 plus 4, 5. Same way, when you substitute n is equal to 2, you will be getting f1 of 2 is equal to x of 2 plus x of 6. When n is equal to 3, f1 of 3 is equal to x of 3 plus x of 7. Same way for f2 of n, when n is equal to 0, it will be equal to x of 0 minus x of 4. When n is equal to 1, equal to x of 1 minus x of 5. When n is equal to 2, it will be x of 2 minus x of 6. When n is equal to 3, you will be getting x of 3 minus x of 7. So here we will see how to draw the butterfly flow graph for DIF algorithm using these 8 expressions. Here I am considering n is 8. So I am writing x of 0 to x of 7 for the input end. Okay. So this is your first stage of DIF. First stage will be 8-point DFT. Okay. So your output is f1 of 0. Here f1 of 0 is equal to x of 0 plus x of 4. So I am considering first input as x of 0 and I am considering second input from x of 4. So at this point I will be getting x of 4 plus x of 0. Okay. Same way, what is f1 of 1? X of 1 plus x of 5. So first input is x of 1. Second input I am taking from this point x of 5. So at this end your answer will be x of 1 plus x of 5. Same way for f1 of 2, x of 2 plus x of 6. For f1 of 3, x of 3 plus x of 7. Next, coming to f2 of 0, what is f2 of 0? X of 0 minus x of 4. So I am introducing minus 1 factor here. So if I multiply x of 4 with minus 1, I will be getting minus x of 4. Second input comes from here plus x of 0. So f2 of 0 is equal to x of 0 minus x of 4. Same way here I am introducing minus 1. So I will be getting f2 of 1 is equal to x of 1 minus x of 5. f2 of 2 is equal to x of 2 minus x of 6. f2 of 3 is equal to x of 3 minus x of 7. So this is your first stage of computation in DIF algorithm. Okay. Now look at your expression. So along with f2 of n, you have the Prudhoe factor value Wn power n. So I am multiplying with W8 power 0, W8 power 1, W8 power 2, W8 power 3 here. Okay, understood? Here we have Wn power n in this odd expression. So I am multiplying this term with W8 power 0, W8 power 1, W8 power 2 and W8 power 3. Okay. So DFT of n point sequence, DFT of n point sequence can be considered as DFT of n by 2 point sequence. Here we have f1 of n along with DFT of another n by 2 point sequence. Here we have f2 of n along with W n power n. Okay. So this is DFT of n by 2 point along with f2 of n and Prudhoe factor. And here we have DFT of n by 2 point of f1 of n. That is what I have written here. That's it. This is how you have to compute the first stage of DIF algorithm. In the next video, we will be drawing the overall flow graph. Overall flow graph in the sense, for 8-point DFT, it can be written as 2 power 3. So 2 mentions your radix and 3 mentions your number of stages. So we have to draw other 2 stages for the overall computation purpose of DIF FFT algorithm. Okay, so we will see that in next video. I hope you have gotten clear idea about how to derive the expression for DIF FFT algorithm. Yes, thank you. See you in the next video.